Hello and welcome in this YouTube channel. Today we are going to learn about the working of transformer. As we know that transformer is widely used in any kind of electronic device and in any kind of substation, electric power plant, and in different type of distributive poles, okay, of electric poles in our household areas. So now in this video we are going to talk about what is the transformer, why it is used for, and how does the transformer actually works. Okay, now I want to enter in this topic without any taking time. Transformer is actually those devices which are used to increase or decrease the voltage, okay, that is AC voltage. It is used for increasing or decreasing AC voltage rather than the DC voltage. We will talk why it is AC voltage and why it is why it is not used for the DC voltage. Okay, I want to show you the internal structure of transformer. As we know that the internal structure of transformer is like this, okay. If we don't know, then also we come to know here that the internal structure of transformer consists of a primary winding, and that is called a primary winding means those we call it as a voltage in, okay, whatever the voltage we give in the transformer, that type of voltage is winding, okay, it is coiled in a transformer. That type of number of coil is known as a primary winding. And this is a laminated iron core, okay, we need a iron core which is laminated, okay, which will be in the form of sheets. Okay, there are many sheets of iron, okay, you can see there, okay, it is connected, and we need a secondary winding for this, for this, okay, secondary winding. Now we have this thing, okay, it is the internal structure of transformer, and it is used for either increasing or decreasing the voltage. And those transformer which is used for increasing voltage, we call it as a step up transformer, and those transformer we use for decreasing voltage is known as a step down transformer. Okay, primary winding means this one, okay, laminated iron core means this one, and secondary winding means this one. Now how does it multiply the voltage? Step up means increasing voltage, step down means decreasing voltage. Suppose we give here voltage in, whatever voltage we supply it as a input, okay, this will be the input voltage. Now there is the number of turning, okay, number of turns in this area, that is called the, let it be called as a NP, okay. We call it why we call it as a NP means we call it as a primary turning also, okay, number of primary turns, and this one is the number of secondary turns, and this one is the voltage output, okay. As we know that these two wires are not tossed with each other, that means the voltage is induced in the secondary coil. So it is not so that the voltage is multiplying, okay, by touching the coil, okay, the coils are not being touched with each other. The interesting fact is here how the internal input voltage will be increased to the secondary output voltage, okay. Now we will see that when applying a AC current in the primary winding, okay, whenever we apply a AC current, we know that AC current electrons fluctuate the distance, okay. I have already uploaded the video regarding AC and DC voltage, what type of electron flow will be there in AC and what type of electron flow will be there in DC voltage. You can see there in this channel only, okay. The AC voltage have the fluctuating frequency, okay. That means in any point of time the positive and negative terminal are being changed. So that's why whenever we know that if a electric current flows in a wire, then the magnetic field is induced, and the induced magnetic field is so much less that it can be negligible. But if the same wire is formed in the form of coil, then what happen? The magnetic force will be large in this area, okay. If the wire is made straight, then the negligible amount of magnetic force will be there. If the wire is made as a round, okay, as a turning, as a winding, then the magnetic force increases. As a result, AC current have a fluctuating electron flow and fluctuating positive and negative terminal in it. So as a result, it creates a pulsating magnetic field. Pulsating means the varying magnetic field. It is not that if you keep a magnet here, then its magnetic field will be from north to south pole. It will be constant, okay, it will not be changing, but it creates a changing magnetic field as a pulsating magnetic field, due to which a magnetic force will be induced in here as a induced EMF, okay, as a induced EMF. Okay, when we supply a electric current, then the electric current induce here the magnetic force, and this magnetic force is given a certain direction to go to secondary turning with the help of this laminated iron core. If there is no any iron core, if this is will be in the air, then what even the magnetic field will be lost. Okay, it will not be given a proper direction to go to the secondary turning. Now what happened, the magnetic field, okay, the varying magnetic field will go to the secondary turning, and what even it cross the secondary turning, this line of force get crossed by a varying way, by fluctuating way. So as a result, electricity and magnetism are interrelated with each other. Electric force creates a magnetic force, and when a varying magnetic force goes to the secondary turning, then what happen, it again creates a electric force. Okay, it again creates a electric force. It is due to the Oersted discovery. Okay, I will upload this video later, but right now you understand that whenever a magnetic field is created in a primary turning, it will get a direction by this help of laminated iron core, and what happen, the secondary turning will get this type of varying magnetic field. As a result, the voltage will be output. As a result, due to this varying magnetic field, the current will be induced, and that current will be taken as a output voltage. This ns means the secondary turning, np means the primary turning. We can call it as a primary voltage bp, and we can call it as a secondary voltage bs. This is the basic diagram of the transformer. Now how can we make this transformer as a step up, and how can we make this transformer as a step down? Okay, now I want to talk about that. Step up transformer is those transformer whose number of secondary turning will be more than the number of primary turning. Suppose we can call it as a ns is greater than np. Suppose in this case, if the number of primary turning is 5, then the number of secondary turning should be 6 or 10 or 100 or anything else, but it should not be less than 5. Now, what type of transformer is step-down transformer whose number of primary turning is more than the number of secondary turning? That means if the secondary turning is less, then the output voltage will be less. If the secondary turning will be more, then the output voltage will be more, because the input voltage is constant whatever we give. Okay. Now, step up transformer helps to increase the voltage, output voltage. Step down transformer helps to decrease the output voltage. Now we have a simple calculation formula for this one, and after that I can give you a little bit one idea about this too. So now we want to go to the formula of this transformer. Okay, now I want to take this paper. This is our transformer. We have a formula, a simple formula, n by v is equal to n by v. Okay, n by v is equal to n by v. Suppose we take this for a primary one, and then we take it for the secondary one. Okay, it is no any difficult to get this. Now suppose we have a number of primary turning is 10. Okay, number of primary turning is 10. That means it is doing 10 round here, and we supply a voltage input that is 220 volt, which we use in our house. Then if the number of secondary turning is how much, 20. Okay, that means we are sure it is a step up transformer. Now let us see the voltage, output voltage, secondary voltage. Okay, this is a primary voltage, input voltage. What will be the value of this? Suppose npbp means 10, number of turning 10 and 220 volt is equal to ns will be equal to 20, and this is the number of turning we need to find bs. Okay, suppose now we can remove this voltage. Okay, later on at last we can use this. Now what we'll do, we'll cross multiply. We know that Bs will multiply 10, 10 multiply Bs, okay, will be equal to 20 multiply 220. Now what happen? Bs will be equal to 20 multiply 220 by 10. Now you can cancel this. Now 22 2s are 44 and 1 0 will be there. Okay, 440 volt of output voltage will be calculated by this one. Okay, you can see here 0 0 cancel. Okay, and here 440 volt of output voltage will be taken. Now we know that in this case the number of secondary turning is more, that's why the output voltage is more. Okay, now I want to give you one idea. You can see here number of primary turning is 10, secondary turning is 20, that means twice. Twice means the voltage will be twice, 220 will be 440. If you take number of primary turn 10 and secondary turn only 5, that means if the secondary is half, then what happens? The voltage will be, output voltage will be less. It is a step down transformer, so the output voltage will be 110 volt. Okay, this is the thing to be known. So today in this video we know about the working of transformer, internal structure of transformer, why it is used for. Okay, and after that we know about the simple calculation. Now one thing, okay, I want to discuss here. Then you may have question in your mind, why we cannot use a block of iron? Okay, why we should use the sheets of iron, laminated iron sheets? If you do not use this one, then I have told the magnetic pulsating magnetic force will be lost, so it will not be able to get the direction. So that's why if you use here a block of iron, okay, big block of iron rather than the sheets, then what happen, all the magnetic force, okay, will be induced in this iron, and as a result of the magnetic force there will be the heat production in this iron. Okay, we call it as a eddy current. Okay, the heat is produced. I repeat once, due to this, if you use a block of iron without any lamination, then what happen, this one induce this magnetic field also induce a current, because it is inducing current here in the conductor, then it obviously induce a current in this iron core also. So due to this, there is, if there is a current induced, then there this iron core gets hot. Okay, gets hot. This is due to the power loss. Okay, due to the power loss, because we are supplying voltage and some voltage is using by this iron core to get heated. Okay, that type of waste amount of current is known as eddy current. So in order to remove the eddy current, we are using the laminated iron core and we are using the sheets of iron core. Although due to this the loss is minimum, so you can see this. So in this video now I want to stop it because it is of 30 minutes time. So we learned about the working of transformer. So if you like this type of video, then you can join my channel. We'll meet again. Okay, don't forget to leave your useful comment. It will be useful for me to generating others video in the coming days. So it's time to take a goodbye. Bye bye.